All right, so this will be our last recording of the semester. And what I want to end with is a little bit of island biogeography and landscape biology. And so we're going to talk about MacArthur and Wilson. So this MacArthur is one of the two brothers from before, and this is E.O. Wilson, the ant guy. So anyway, in the 60s, they looked at island biogeography, and what they did is they went to some islands and actually worked on birds. And from that paper, and this is an important paper because this is one of the first times that they actually used statistics in these types of papers. MacArthur was actually a mathematician. And again, E.O. Wilson was an ant guy, but also did a lot of biodiversity. So they came up with this idea of island biogeography, and you can see these three graphs. And they can or cannot be confusing. But what I want you to get you to know is that each island kind of has an equilibrium number depending on where they're located in size and things. And that is what they're showing you with this little thing here. And so this is kind of the magic number, and they don't really give you a number here. But they look at immigration and extinction rate. So the idea is that this island would, for example, hold 5 species. So let's use that as our, sorry about that, just checking. Let's use that as our example. What happens is if they went back 3 years later, there'd still be 5 species, because that's how many species of birds that island can maintain. Now, what they found surprising, though, is they may be different species. In other words, maybe 4 of them are the same and another species appeared. So, which means one actually went extinct. So one disappeared from the island and one immigrated in. So you get this magic number. The second thing they found out is effective island size, and it gets a little bit bigger, the graph. And what this magically says, if you look at it kind of down here, is small islands have less species than large islands. So that's pretty simple, I think, which makes sense. The larger island has more niches. And then you move all the way to the far side, and what you're going to see is number of species on an island, depending on their distance from a mainland. And the mainland is defined as an area that has populations that can transfer and end up on these little islands. So this last one saying is islands that are far away have less species than islands that are closer to the mainland, which makes sense. And so all of this, I need you to know to kind of understand how this works. So, there's also this thing called a species area curve, where you can see that the larger island, again, usually area alone will give you more species. And this is another equation that has been done for quite a while. So more area gives you more species. It's not rocket science. And it comes down to more niches. So here are a bunch of islands. These are the Galapagos Islands. And then the idea behind this is who would have the most species. So what you're looking at is probably, I would guess, South Albemarle would be the one. It's the largest one. And then, you have different islands with different sizes. So I look here at Chatham and I look at James, and I'm, kind of deciding, well, which one of these have more species. And again, because of the same size, you'd expect them to have more, or the same amount of species. Maybe one of them would have more because they're closer to the mainland. So the question is, where the mainland? If you look up here, Ecuador is that way. So I would guess that Chatham would have the more species on that. So this is kind of what they did and looked at and figured out. So I want you to know that big paper in ecology. So island biogeography is looking at islands, but as we look at land on the mainland, what we're doing is we're chopping it up, we're fragmenting it. And if you look at this now, what it looks like is a bunch of islands. So although we have this mainland with this continuous, what used to be a continuous habitat, it is now broken into these fragments, which are causing all kinds of problems. So this fragmentation is going to affect biodiversity. So if you look at here, you can see, you know, we've got 4 species. And at that point, we have these rivers. You can see the little blue arrow suggesting that these guys could get across, you know, and all good. You know, so these have regular, this one not quite so regular. But if you move over after a dam has been put in, what you're seeing is we got blockages now that we're not seeing this crossing. So we get infrequent, maybe from 3 to 4, but 3 has shrunk quite a bit. 2 is typically isolated. We have no more movement whatsoever. Maybe S1 is not affected at all so far. But again, what we're trying to show you is what we're doing is we're breaking this up into little tiny islands. All right, so as you do this, you get something called the edge effect. And so these are some habitats that have been destroyed. And what you're seeing here now is we have this edge that might not have been there before. And the edge effect actually causes issues. Okay, so there are species that like to live on these. These are called ecotones, and I want you to know that term, ecotones. And that's an area between 2 habitats. And the idea is you kind of have the best of both worlds. You got pieces from each. So there are some species that thrive under these conditions. But for the most part, species don't. And here's what I want you to realize. If you have this deep forest and you're in here, there are predators out here that aren't going to travel very far in here. They may go a little bit and kind of look around at the edges, but they're not going to go in very far. Same down here. But now we have all this area that's open, and predators may be willing to walk through here. And before, if this thing was all large, they wouldn't. Let's say this is, you can see the ag land, so maybe they go in just a little bit. But here they go in that same distance, they're almost halfway there. And these then they start missing species. So 2 different types. This is a tropical rainforest that's been clear cut, and this is a forest that has been used for grazing. Actually, I've shown you 3 species here that actually like these areas and have benefited. One is the rough grouse you see there, because what happens is they like the forest to hide in for protection, but they will go out to feed in the grassland and also to and do some of their rituals out there for mating. The brown-headed cowbird is a brood parasite. It actually lays its eggs in other birds' nests, and it finds that these do not, they're really kind of a pasture bird. They like these open areas like this. And so what they do is they hammer the birds that are on the edges. And the problem, again, if you get a small one like this, they're going to hammer from all sides, and pretty much the species that they are using will eventually disappear. And then the white-tailed deer, same thing. They will, they like the forest cover, but they will also go out in the open to feed. So here's an idea we want you to understand, that if I have to have smaller areas, what I need to do is have some kind of corridors set up. And these are wildlife corridors, or sometimes they're called moving corridors, I think is what your book calls them. But they're a way for organisms to kind of move along and pass through and get to an area. And we'll talk about this in our last meeting, actually, when we do the wildlife sanctuary lab. So here's another one. You know, we have 2 ways to cross species. So what they're doing now are building these overpasses and planting them using these as wildlife corridors, or they're going underneath. This is actually an ocelot down in Texas, and to keep these off the freeway from getting hit, they've made these underground tunnels that allow these cats to go back and forth. So again, corridors. So again, I would actually love to have a big, you know, if I'm a landscape, looking for landscape biologists or conservation biologists, and one of the things I'm looking to do is, if I've got money, I get the biggest habitat possible. That makes sense. And if the habitat is not possible, and I have to get 2 smaller habitats, then what I really want to make sure I have because I want to try to minimize the edge effect. But one of the things I want to do is put the corridors between them so the organisms have the ability to flow back and forth. I want to kind of step out and talk about what we need to do is, we have the Endangered Species Act, and I'm not saying that's a bad thing. But maybe we need to stop worrying about single individual species and start saving landscapes or habitats. And Costa Rica now is usually used as the example of something that can be done. Costa Rica was terrible at one point, and they were cutting down the rainforest. And why they were cutting them down, the scary part is because they owed other countries, USA, money. And so what was happening is they were cutting down the forest, which happens, we understand that, but they were cutting down the forest to pay interest on their debt. So once their forest was gone, they still owed us the principal. And so finally they figured out that's not a good idea. So they started looking around and they decided to begin to protect their land and protect the oceans around them. And instead of cutting it down, they actually raise money and would pay the people around there to save it. At one point, they were actually subsidizing farmers to cut down forests, and they stopped doing that. And now they were giving money to local people to not do that. And what they figured out is it was because of their main crop. And in class, I usually ask what you think that crop is, and it turns out people say coffee and this and that. It turns out it's tourism, which is not really a crop, but they found out that if they saved the land, the people would come and visit. And Costa Rica now is very high on ecotourism. They found out that rich Americans and rich Europeans would actually travel to come see their area. And so they have some of the better forest out there because of this, because they're not only protecting, you see protected lands, which is the dark green, but then also some of this lighter green area is also reserve, not quite as protected, but it does support. And again, if you live on the edge of this, these people are paid. It turns out when we went down to Costa Rica and toured, we had a guide, and our guide was very knowledgeable, very, very cool guy. And it turned out that he used to be a teacher, and he could make more money being a guide. And to be a eco guide in Costa Rica, you have to have a college degree, and you have to continue to take courses. You have to be certified because they want it to be a positive experience, so people come back and spend money. So they're doing a great job of saving land. So again, I'm trying to show it to you here. And the other thing I want you to realize is that when we're doing this, there's also these areas what we call terrestrial hotspots and marine hotspots. And what those are this is where heavy biodiversity is. This is where the species still are. So if you look here, you can see there's hotspots here. Obviously, with both the land and marine areas, these are called MPAs, marine protected areas. But again, if I am a person trying to save species and I'm buying up land and trying to, where do I put that land? I put it on the hotspots. Again, the largest area I can on a hotspot would be ideal. And again, if that doesn't happen, maybe, just maybe, I put smaller pieces with corridors between them. But again, ideally, you put it on top of these hotspots. And California is a hotspot. We are a hotspot for coastal sage scrub. Us and the Mediterranean are two places that we still have coastal sage scrub and chaparral. And with that, we will call it a semester.